This video is on solving two-step equations. It's lesson 23 in your book, and it's on pages 134 through 136. Remember that the goal of solving equations is to figure out what number you can plug in for the variable that will give you a true statement. And in order to do that, we often have to use inverse operations. Remember, the inverse of addition is subtraction and vice versa, and the inverse of multiplication is division and vice versa. Now, these equations that we're going to solve have multiple steps, so it's not just one step like before. We're going to be doing more than one step. When we solve equations, we always use the order of operations, but we use it backward instead. Since we're undoing an equation, we're taking it apart instead of simplifying like an expression, we use the order of operations backward. So we undo addition and subtraction first, then we undo multiplication and division, then we undo exponents, and then finally we undo parentheses. So we go in the opposite order. Now, the best way to figure out how to solve an equation is to figure out what you would do with it if you had a number for the variable. So we're going to pretend like we know what x is. Now, if we knew what number x is, the first thing we do to simplify this would be we'd multiply it by 3. And then after we multiply 3 times whatever x is, the next thing we do is subtract 2. Now, when we solve an equation, we're actually undoing all of these steps. So we're going to do the opposite operation in the opposite order. So I'm going to start with the very last step I wrote down, subtract 2. And I'm going to do the opposite of that. So the inverse of subtraction is addition. So the first thing I'm going to do is add 2. Now, when I add 2 to one side, I also have to add it to the other side. I can bring my 3x down. Minus 2 plus 2 is 0. And 4 plus 2 is 6. Alright, so I've taken care of undoing the last step. Now I'm going to move up. The step before the last step, in this case the first step, was multiply by 3. Now, I want to do the opposite of that. So to solve this equation, I'm going to divide by 3. And I have to do that to both sides of the equal sign. That takes care of undoing my next step. Now, 3 divided by 3 is 1. Sorry. So then I'm just left with x on that side. And 6 divided by 3 is 2. So my solution is x equals 2. I can check and make sure it's correct by plugging it in to the original equation for the variable. So 3 times x, which I said was 2, minus 2 equals 4. 3 times 2 is 6. 6 minus 2 is 4, so now I have a true statement, 4 equals 4. So my solution for this equation is x equals 2. Here we have another one. 4x plus 5 equals 17. So first we're going to look at what would we do if we knew the value of a variable. How would we go about doing this? So the first thing we would do if we knew the value of the variable would be to multiply by 4. And then once we multiplied 4 times x and we found an answer there, we would add 5. Now, to solve this equation, we're going to do the opposite operations in the opposite order. So I'm going to start at the bottom. The last thing I said I would do would be to add 5. So I'm going to do the opposite of that and subtract 5. I have to do that to both sides of the equal sign. I can bring down my 4x. 5 minus 5 is 0. And 17 minus 5 is 12. So I've taken care of undoing that last step. Now I move up to the next to last step, multiply by 4. And I'm going to do the opposite of that. So I'm going to divide by 4. 4 divided by 4 is 1, and then I have an x. And 12 divided by 4 is 3. I can check it and make sure it's correct by plugging 3 into the original equation for x. That would give me 4 times 3 plus 5. 4 times 3 is 12. and 12 plus 5 is 17. So now I have a true statement, 17 equals 17. So this is my solution for that equation. That's the number that I can plug into that variable to make the equation true. Now this is an example. The example on the previous page also needs to be in your notes, and then we'll have two more after this that also need to be in your notes. So pretty much every page of this video needs to be in your notebooks. Alright, here's another example. This one's similar, except that it has negative coefficient of your variable instead of a positive coefficient, but we do the problem the exact same way. So I'm going to look at it and decide what would I do if I was going to simplify this. If I knew what m was, I would multiply negative 5 times m. That's the first thing I would do, so I'm going to write that down. I would multiply by negative 5. Now once I multiplied negative 5 times m, the next thing I would do would be to add 6. Now to solve this equation, I'm going to do the opposite operations in the opposite order. So the last thing I said I would do would be to add 6. So I'm going to do the opposite of that and subtract 6. Now I have to do that to both sides of the equal sign. 8 minus 6 is 2. Bring down my negative 5m, and 6 minus 6 is 0. Alright, so I've taken care of undoing the last step. Now I move up to the next step, which was multiply by negative 5. And I'm going to do the opposite of that. So I'm going to divide by negative 5. Now here I have a positive divided by a negative, so I know my answer is going to be negative. And 2 divided by 5 is just 2/5. Negative 5 divided by negative 5 is 1. And I've got my m right there. So my solution is negative 2/5. I can check and make sure it's correct, again, by plugging it into the original equation for m. Now negative 5 times negative 2/5, my negative 5 on top and my negative 5 on bottom cancel, and I'm just left with 2. And 2 plus 6 is 8. 8 equals 8 is a true statement, so this is my correct solution. M is negative 2/5. Now here's another example, and this one has fractions in it instead of whole numbers or integers. However, we do the problem the same way. Now there's one little trick that we can do to make this equation a little easier to deal with. I can eliminate all these fractions. And the way that I do that is I can look at my denominators. Here my denominators are 2, 3, and 4. And I can decide what is their least common multiple, or what number can be evenly divided by all 3 of these numbers. Now, the least common multiple of 2, 3, and 4 is 12. So I can multiply both sides of this equation by 12 to make these fractions go away. Now on the left side you will have to use the distributive property and multiply 12 by each term inside the parentheses. 12 times 1/2 is 6, and then we've got an n there. And 12 times 1/3 is 4. So when I multiply this using my distributive property, I get 6n minus 4. Now 3/4 times 12 is 9. Now see how I multiplied both sides by the same number. The multiplicative property of equality says that's fine, my equation is still true. But just by doing that simple step, I got a much less complex equation to work with. So now I'm going to solve 6n minus 4 equals 9. Now if I knew what n was, the first thing I would do would be to multiply 6 by n. Or multiply n by 6. And then once I multiplied 6 times n, the next thing I would do would be to subtract 4. So to solve this equation, I'm going to do the opposite operations in the opposite order. So the last thing I said I would do would be to subtract 4. So the first thing I'm going to do is the opposite of that. I'm going to add 4. and I have to do that to both sides of my equal sign. I can bring down my 6n. Negative 4 plus 4 is 0, and 9 plus 4 is 13. Now I go up to my next to last step, multiply by 6, and I'm going to do the opposite of that. So I'm going to divide by 6. 6 divided by 6 is 1, so on that side I'm just left with n. And 13 divided by 6 does not simplify, so we're just left with 13 divided by 6. So the solution to my equation is 13 divided by 6. Now I could go back and check that by plugging 13 over 6 into my original equation for n. And here's our final example. Again, all this stuff needs to be in your notebook. It says a gym charges a $90 fee plus $30 per month. Another gym charges a fee of $1,500. How many years will it take for the charges at the first gym to reach $1,500? Okay, now they don't actually give us, the question says how many years will it take for the charges to reach $1,500. But they don't actually give us the yearly charge. But we can figure out the yearly charge. If they charge $30 per month, and there are 12 months in a year, every year we'll pay 30 times 12. So that would be $360 in monthly charges per year. Now, they also charge that $90 fee. So we know we're going to pay $90 right off the bat. And also, we're going to pay $360 for every year, which I'm going to call Y. So the first gym charges that $90 plus $360 per year. And we want to know how many years will it take for those charges to equal $1,500. So we have an equation here. 90 plus 360y equals 1,500. And we want to figure out y. How many years will it take? If I knew what y was, I would multiply 360 by y. So that my first step would be multiply by 360. Now, after I multiplied y times 360, the next thing I would do would be to add 90. In order to solve this and figure out what number I could plug in for y to make it true, I'm going to do these steps in the opposite operations in the opposite order. So the last thing I said to do would be to add 90. So instead, I'm going to subtract 90. Now 90 minus 90 is 0, and that gets me 360y on the left side, equals 1,500 minus 90 is 1,410. Now I've taken care of that add 90 step. Now my next step says multiply by 360. So I'm going to do the opposite of that. I'm going to divide by 360. And if I do that to one side, I have to do it to the other side. Now 360 divided by 360 is 1, so I'm left with y. And 1410 divided by 360 is about 3.92. So it's going to take me about 3.92 years for that first gym to catch up with the second gym in respect to charges. Or you can round it to about 4 years.